So the solutions to the Isaac physics questions I set you. If we start with 4.1, you only have 5 newtons to the right. Hopefully you've appreciated that with the horizontal forces, right is positive, with the vertical forces, up is positive. So the answer is 5 newtons. Two forces then, we have 6 to the right, 4 to the left, so we've got 2 newtons. Here we have 4 and 4 in each direction, so the resultant is 0 newtons. Here we have 5 to the right, 7 to the left, so that's minus 2 newtons. The first one with a sign has been crucial to getting the answer right. 5 to the right, 4 and 7, which is 11 to the left, giving you minus 6 newtons. 4 and 5 to the left, 9 to the right, so they exactly balance, 0 newtons. 4 and 6 to the left, 6 and 7 to the right, that's 10 and 13, so that gives you a net or resultant of 3 to the right, plus 3 newtons. 4 forces again, 5 and 6 is 11, 7 and 4 is 11, 0 newtons. 11 and 10, so we have 1 newton to the left minus 1 newton. We have 9 to the left and 11 to the right, so that's 2 to the right plus 2. 10 and 12, 12 to the right then, 2 newtons positive. Vertically, we've got 14 up and 6 down, giving you 8 up, 8 newtons positive. We have 6 up and 7 down, giving you 1 down overall, minus 1 newton. And finally then, 7 up, 7 down gives you 0 vertically, 6 left, 6 right gives you 0 horizontally, 0 newtons. For 2 then, the resultant force on a racing car, 24.5 kilonewtons driving force and 15.2 kilonewtons opposing frictional force. The difference between those two figures, 9.3 kilonewtons. For 3, what is the resultant magnitude of the displacement if a person walks 5 kilometers east and 5 kilometers north and 4 kilometers east? So that's 5 north, 4 east. You want the hypotenuse of that triangle. So if you do the square root of 5 squared plus 4 squared, that gives you 6.4. Notice 3 sig figs here because you've got 3 sig figs here and here. If either of these was only to 2, this would have to be to 2, and the units are kilometers. I think we're on 5.5 now. Weight is a force, force is a vector, so it has direction. What direction is your weight? Towards the center of the earth. That's the case in each of these. Your weight is caused by gravity. Please excuse the spelling of center. It's embarrassing that this is from Cambridge and yet it has the American spelling. I think I might have missed 4.4. Yes. Why is gravitational field strength a vector? Well, the definition of a vector is it has both magnitude and direction. 4.6. A stuntman drives a car out of the back of a moving lorry. For the stunt to work, the car must be moving with a velocity of minus 5 meters per second. The instant it has left the lorry is traveling at a velocity of 25 meters per second. What speed must the speedometer on the car reach before the car leaves the lorry? Well, on the assumption the car is pointing forwards, that is to say, it is driving out of the back of the lorry bonnet first, then the speedometer would have to be reading 30 meters per second so that you have 25 in that direction to overcome the 25 of the lorry, and then leaving you 5 in the reverse direction overall. Hopefully that makes sense. You might have said minus 30. I could understand that, but It is what the speedometer is reading, and although you probably don't know, the speedometer isn't going to read anything if you're in reverse. That's just the way it is. So 30 meters per second is the answer there. That question, not so easy to get right, mainly because of getting your head around what the picture looks like. The numbers aren't very difficult. So we're on 4.7 now, I think. Using a scale diagram, calculate the resultant force acting on a sailing boat. When an easterly wind, that is a wind from the east, 2.50 kilonewtons, note the 3 sig figs. The tide provides 1.20 kilonewtons from a direction 30 degrees more northerly than the wind. Give the answer to 2 sig figs. So let's have a look at 4.7. So we have 2.5 easterly, and then we have the wind, the 1.2, or the tide, sorry, 1.2, at an angle which was 30 degrees more northerly. So the wind's coming in from here, with this angle being 30 degrees. So we have 2.5 kilonewtons like this, we have 1.2 kilonewtons like this, and then you have your resultant of those two would be there. So measuring the length of that, 3.5 kilonewtons. So again, this is a question where I think seeing what the question is asking is the challenge, rather than actually drawing the diagram. I know it looks like my 1.2 kilonewtons starts here. It doesn't. It starts here. This was the arrowhead of the 2.5 here. So my 1.2 vector runs from this point to this point. So there's 4.7. 4.8 then. You have a 10 kilometer east followed by a 5 kilometer south and a 2 kilometer west hike. And we want the bearing. And it tells you that bearings are measured with north being 0 and measuring clockwise. So let's have a look at 4.8 then. So there's our easterly walk, followed by our southerly walk, followed by our westerly walk. So we started here, we ended up here, and the bearing then is measured from north being 0 round to this direction, which is 122 degrees. Hopefully you've measured that accurately. Finally then, 4.9. A kite is in equilibrium so that the total sum of the forces is equal to 0. That's what equilibrium means, no resultant force. On a vector diagram, the arrows representing the forces would form a closed loop. This is one of the things that you can do to verify equilibrium or to establish the force required to produce equilibrium by drawing this scale vector diagram. You're given 3 of the forces, the force from the wind, the weight, and the tension. The wind produces a horizontal force of 70 newtons, 70.0, an upward force of 50.0 newtons, and the kite weighs 25.0 newtons. So you've got your 50 newtons upwards due to the wind. You've got 25 newtons, which I've tried to draw in black, in the opposite direction. That's the weight. And you also had, well, I should have started with your 70 newtons horizontally. So you've got 70 and 50 from the wind. And then you've got 25 newtons from the weight. So in order for this to be in equilibrium, we go from here to here, we would need a force like this to keep it in equilibrium. Notice the direction. If you have a closed triangle or a closed polygon, a closed shape, when you draw all your vectors the right length and directions, then your object is in equilibrium. That's an important point for you to note there. So here we have 70 and a net of the 50 and 25 of 25. 70, 25. So if you just had those two forces, then your resultant force would go from here to here. You would have the 75 Newton resultant force. But you are told that this kite is in equilibrium, which means that the tension in the string forms the other side of this triangle, and it runs from here to here in order that you have this closed triangle following from the tail of one arrow round through the head, through to the head of the next, through to the head of the next. So if the arrows follow in their direction like this and form a closed shape, that object is in equilibrium. I've tried to indicate that over here. So the difference between this question and the previous questions is that the previous questions were asking you to work out the resultant force. So you would have had 70 and a net of the other two of 25 there. If those were the only forces you had, then the resultant force would go from where you started to where you finished, 75 newtons in a bottom left to top right direction. In this question, you're told that all of the forces form a closed polygon. In this case, it ends up being a triangle because the 25 newtons is collinear with the 50 and in the opposite direction. So it reduces the 50 to 25 in effect. So if it's an equilibrium, you have this closed triangle, which means you go from here to here to here, and then the tension closes the triangle in this direction. 75 newtons if you measure that line. So there you have the solutions. Final part then measuring the acute angle the string makes. Measuring that angle is 20 degrees. Of course, it could have made this angle here. We might have chosen an angle with the vertical, but in order to make sure you wrote down the right angle, the question asked you for the acute angle with the horizontal, because this one obviously is also with the horizontal, but it's not acute.